going to work through this practice test 7. Hopefully this will help you in preparation for the actual test. So number 1, let U be the universal set where U is the numbers 1 through 30. A and B are subsets. So we want to list the elements in the set A and B. So this intersect is an and that means the things that they have in common. So let's see, A has 8, so does B. 9, 10, 12, 13 is in common. 14, 18, 20, 21 is in common. 23 is in common. So those are the only numbers that A and B have in common. So A intersect B would include the numbers 8, 13, 21, and 23. The next one is the list the elements in the set A union B, or A or B. So this is all of the numbers in either set. So it's combining everything together. So this is going to be a much longer list. So it's 3, 5, 8, 9, 10, 12, 13, 14, 18, 20, 21, 23, 24, 26, and 30. So anything that appears in either set is going to go into the union. All right, the third part is list the elements of the set A union B complement. So since we have A union B, we just did that. The complement of that set is anything that's in the universe that is not in A union B. So that would be 1, 2, 4, 5 is in the set above, 6 and 7 is not, 8, 9, 10 is in the set above, 11 is not, 12, 13, 14 is in the set above, 15, 16, 17 is not. So you see we're just listing everything that's not in the list above. That's the complement. All right. So that will be the list of elements in the set A union B, the complement of A union B. Okay, and then finally, list the elements in the set, the complement of A and the complement of B. So this one we need to make the two sets appear first. So we're going to list everything that's not in A. So that would be 1 through 7, 8, 9, 10, 11, 15, 16, 17, 19, 22, and then 24 through 30. And then the complement of B, 1, 2, 4, 6, 7, 9 through 12, 14 through 20, 22, 25, 27, 28, 29. Okay, so now we want to know what these two sets have in common. So they both have 1, 2, 4, 6, 7, 11, 15, 16, 17, 19, 22, 25, 27, 28, and 29. All right, number 2. A boy owns 2 pairs of pants, 7 shirts, 5 ties, and 6 jackets. How many different outfits can he wear to school if he must wear one of each item? So for this, you're just multiplying all of these numbers together. So this will be 2 times 7 times 5 times 6. That's 420. So it's 420 different outfits if you're combining one of each of those items. Number 3, a school dance committee is to consist of 2 freshmen, 3 sophomores, 4 juniors, and 5 seniors. If 6 freshmen, 9 sophomores, 8 juniors, and 8 seniors are eligible to be on the committee, In how many ways can the committee be chosen? So since the order does not matter for this selection, like it's not a president, a vice president, it's just people on a committee, you do want to separate it into classes. So you have freshmen. So 2 freshmen are going to be chosen from the 6 possible freshmen to choose from. So that's going to be a combination. 6 choose 2. Okay, and then you're going to have sophomores. You can choose 3 out of a possible 9. So you'll have a combination of 9 choose 3. Okay, then we have juniors. You're choosing 4 out of 8. So that'll be 8 choose 4. And then you have seniors. And out of 8, you're choosing 5. So 8 choose 5. So you're doing these combinations. If you have an 83 plus, I'm guessing an 84 or an 84 plus would be similar. If you go to program, nope, I'm sorry, not program. If you go to math, you hit the math button, and then you go scroll over until you see PRB, which is probability, you will see that you have combinations and permutations in your calculator, so it will actually do it for you. So as long as you at least show the notation that I showed here, that you know it's a combination and you know how many you're choosing out of how many total, it's fine if you use your calculator to find these. So the combination 6 choose 2 would be 15. And if you don't use your calculator, that's fine. You can do it by hand. Let's show how to do this one, and then you'll be able to apply it to the others. This is going to be n factorial over r factorial n minus r factorial. So n is 6, r is 2, n minus r is 6 minus 2. Okay, so that's going to be 6 factorial over 2 factorial. 6 minus 2 is 4. So you could rewrite this as 6 times 5 times 4 factorial. 2 factorial is just 2 times 4 factorial. So the 4 factorials cancel out. 6 times 5 is 30. 30 divided by 2 is 15. So that's how you do it by hand. If you do it with a calculator, that's fine. You'll see that you get 15. I'm going to do the rest of these using the calculator, but feel free to do it by hand if you don't know how to use your calculator or you don't have the calculator that will do it for you. So 9 choose 3 is 84. Then we have 8 choose 4 is 70. Oops. And then we have 8 choose 5, and that's 56. And so since each of these are mutually exclusive, they're independent, they don't depend on one another, you're going to multiply all these numbers together. So you're going to have 56 times 70 times 84 times 15, and that will be 4,939,200. So that's the number of ways that a committee can be chosen given the information provided. Okay, number 14. I'm sorry, number 4. Okay, so number 4, a pianist plans to play 3 pieces at a recital from her repertoire of 21 pieces and is carefully considering which song to play first, second, etc. to create a good flow. How many different recital programs are possible? So in this case, order does matter. So in number 3, it didn't matter who was picked to be on the committee. They were still on the committee. But this does matter because the song you play first and second and third, there's an order to that. So this would be a permutation. So the permutation You have 21 possible songs, and you could pick 3 of the 21 that you know. So this is what we would do, permutation, to find the answer here. So this formula is n factorial over n minus r factorial. So that would be 21 factorial over 21 minus 3 factorial, which is 21 factorial over 18 factorial. You can continue doing this by hand. So this would be 21 times 20 times 19 times 18 factorial over 18 factorial. So those cancel. And it turns out you're really just multiplying 21 times 20 times 19, and you get 7,980. Okay, number 5. We have this Venn diagram. It says find the number of elements in each of the following sets. So I'm not going to quite be able to, oh, I can. Okay. So this will allow me to fit everything on the screen. Know that set A is this circle, and the set on the right is B. Okay, so what is the universe? How many elements are in the universe? So for the universe, you want to add up all of the numbers together. So that would be 44. So it'd be 44. Well, let me do it on the side, sorry. Okay, so the 44 plus 18 plus 64 plus 39. And when I added that all up, I got 165. So the universe has 165 elements. How many are in the complement of A? So in A, set A has 44 plus 18. So that's 62. So the complement would be 165 minus 62, which is 103. Alternatively, you could have added everything that's not in A. So we could have just done 64 plus 39, and that also would have given us 103. All right, so now they want the complement of A intersect B. So what's not in A and also in B? So that would just be 64. Okay, let's see, next they have the complement of A intersect B. So first we want to figure out A intersect B. A intersect B is this part in the middle, so that's 18. The complement of that is everything else. So that would be 44 plus 64 plus 39. And that would be 147. All right, and then we have A union B, and then the complement of that. So let me erase this circle. So A union B, that would be everything combined. The complement of that would be just what's outside of that. So that would be the 39 outside of those circles. All right, and then the last one, A complement or intersect B complement. So what's not in A and also not in B? Well, the only thing that's not in A and not in B is that 39 on the outside again. So again, that would be 39. All right, number 6. A bag contains 1 gold marble, 6 silver marbles, and 23 black marbles. Someone offers to play this game. You randomly select 1 marble from the bag. If it's gold, you win $4. If it's silver, you win $3. If it's black, you lose $1. What is your expected value if you play this game? Okay, so you want to multiply the value times the probability of getting that. So for a gold, there's only 1 gold marble out of, it looks like 30 total marbles. So 1 plus 6 plus 23 is 30. So 1 out of 30, 1 time out of 30, you'll get $4. All right, if it's silver, I I guess I'll just use green. If it's silver, there are 6 silver marbles. So 6 out of 30, you win $3. And then if it's black, that's going to happen 23 out of 30 times. You lose $1, so times -1. So we're going to add up all these, all the things that we get. So 1/30 times 4 is 2/15. So we'll have 2/15. Okay, that's how much we would win over time. 6/30 times 3. That's 3/5. So I'm getting this from here, and then in black, 23/30 times -1. That would be a -23/30. And then we're going to add all those up. All right, so I got a -1/30. So I could have just not reduced these. That would have been smarter. So this would be 4/30. This would have been 18/30. And then we have -23/30. It might be easier to see this way. 4 plus 18 is 22. So this would be -1/30 is what I'm getting. So -1/30, if we're talking about your expected value, you're really talking about money. So if we divided this out, we would get -0.0333 repeating. So approximately -0.03, meaning, again, talking about money, a negative means you're losing, and that's approximately 3 cents. So if you played this game for a really long time, on average, you would lose about 3 cents per game. All right, number 7. Use the table below to answer the following questions. What is the probability that someone is from the U.S.? Okay, so let's kind of look and see what we have here. We have the number of children, we have from the U.S., from outside the U.S., and then total. Okay, so from the U.S., we have 40. So we want to know what's the probability that someone's from the U.S. 40 out of, our total is 100. So 40 out of 100. Then we would reduce that. I don't see it telling us if we need to have a fraction or a decimal. So I guess we can give it as a decimal. That's probably more common. So 40 divided by 100 is 0.4. Okay. What's the probability that someone has at least 2 children? Okay, so that means 2 children or more. So that would include people that have 2 kids. That's here. Or more. So it's all of this as well. So the probability that they have 2 or more kids, total we have 24 and 25 out of 100. So 24 plus 25 is 49. So let's see, 24 plus 25, because 24 people have 2 kids, 25 people have 3 or more kids. So you add that together, that's 49 out of the total 100. So that would be 0.49. What's the probability that someone is from the U.S. and has 1 child? Okay. So this and means we want to find where these things intersect. So they're from the U.S. and have 1 child. So 15 people are from the US and have one child. So that would be 15 out of 100, which would be 0.15. Okay, next we have what's the probability that someone is from the US or has 0 children. So from the US, is 40 and 0 children is 25. But notice there's a piece that overlaps here, which is 7. So you're going to have to take that away from the total. So you would do 40 plus 25, but then we've counted 7 in both of those, right? We counted 7 here and we counted 7 here. So we double counted the 7. So we have to subtract that out. Okay, so 40 plus 25 is 65, minus 7 is 58. So this would be 58 out of 100, or 0.58. All right, the next one, given that the person is from the US, what is the probability that they have 3 or more children? Okay, so this given is going to affect your denominator. So if it's given that they're from the US, now your denominator is 40, so it's only out of 40. What's the probability that they have 3 or more kids? Well, that's 8 out of 40. So 8 out of 40, which is 0.2. All right, given that the person has 1 child, what's the probability that the person is from the US? So now the denominator is the 1 child. So whatever you're given, that's your new denominator. So now it says given that there's only 1 child, so that's your denominator, what's the probability that they're from the US? So that would be 15 out of 26. Let's see what that is. Let's round to 3 decimals. So 0.577. All right. So again, remember with the given statements, the given part is going to be your new denominator. So you're not looking at the total for your denominator now. You're looking at that, the total of that piece for your denominator. All right, number 8. The Venn diagram shows the number of participants in 2 different kinds of aerobic exercise classes that are offered at a health club. You have step aerobics and you have jazzercise, and then you have 12 people in the middle. So the 24 means that 24 people only do step aerobics and they don't do jazzercise. The 23 means that those people do jazzercise but not step aerobics. And then the 12 in the middle means those people do both exercises. They do step aerobics and jazzercise. So determine the probability if a person is selected at random from the participants. Okay, so we're looking at probability here. So first of all, let's find our denominator. So we want to find the total. So that would be 24 plus 12 plus 23 is 59. So our denominator is 59. So the probability is how many people do aerobics and jazzercise. So what's the probability that you would pick a person who likes to do both? So that would be 12. 12 out of 59. So if you want to give it as a decimal, you may enter your answer as a calculation that leads to the answer. Okay, so that means you can put it as a fraction. So 12 out of 59 would be the answer. If you needed to do a decimal approximation, we could say 0.203, depending on where it said to round, but this one is asking for the fraction. Part B, the probability only aerobics or only jazzercise. So that would be the 2 outside numbers, 24 plus 23. So that would be 47 out of 59. 100 students were asked whether they liked certain candy flavors. It was found that 49 liked green apple, 42 liked chocolate, and 26 liked both. What's the probability that a randomly selected student liked neither flavor and then liked either green or apple, or either green apple or chocolate but not both? Okay, so first thing we want to do is make, whoops, let's try that again. Make a Venn diagram. That's not going to work that great. Just a minute, let me just draw it by hand here. Okay, so let's say we have this Venn diagram. Here's one circle. Here's another circle. We have green apple. I'm just going to put GA and chocolate, CH. Okay, so 49 liked green apple. Now be really careful here. That means this entire circle has to add up to 49. That does not mean 49 goes here, because that would be only green apple. It doesn't say that 49 people only liked green apple, just that they liked it. So what you want to do first is fill in the middle. So 26 liked both, so that would go in the middle. If you know that the whole circle on the left, the green apple, has to be 49, you can take 49 and subtract off the 26 that's already in that piece and see how many people are left, which is 23. So now you know that 23 only liked green apple and do not like chocolate. 26 like both green apple and chocolate. And then adding the 23 and the 26 gets you that 49 that like green apple. And now you'll do something similar with a chocolate. So if 42 people like chocolate, out of those 42, 26 like both. So you can subtract 26 from the 42 and you get 16 only liked chocolate. Okay, so now the next thing is there's 100 students that were asked this question. So let me erase our side work here. So this is in a box of 100 students. So what we want to do is we want to add up all the numbers in the Venn diagram. So 23 plus 26 plus 16 is 65. So 100 minus that 65 means that 35 students said they didn't like either of those flavors. So again, it says 100 students were asked. So we know that there's a total of 100 students. We added up all the numbers in the circles, got 65. The 100 total minus the 65 students that said they liked at least one of the flavors gave us 35 students left over. So they must be the students that liked neither flavor. So the answer to part 1, what's the probability that a randomly selected student likes neither, would be 35 out of the total 100. So let's see. Again, it doesn't tell us how to write it. We could write it as a simplified fraction or a decimal. So a simplified fraction would be 7 over 20, or a decimal would be 0.35. Okay, the next part is liked either green apple or chocolate, but not both. So green apple or chocolate, but not both. So that would be 23 plus 16 is 39 out of 100. That's in reduced form. So then as a decimal, you would put 0.39. Okay, let's look at number 10. All right, number 10, we have a group. Let me move it down a little bit. A group of 32 randomly selected adults were asked in a survey if they have either a nut allergy, a wheat allergy, or both. 20 had a nut allergy, 13 had a wheat allergy, 6 had both. Fill in the diagram with the information provided. So this is going to be just like the one we did above. 6 had both, so 6 would go in this middle section. Then 13 had a wheat allergy, so the total red circle, the total circle on the right, needs to be 13. So 13 minus 6 is 7, so 7 would go in this section. And then 20 had a nut allergy, so 20 has to be the total in the left circle, the blue, so 20 minus 6 is 14, so 14 goes there. And then 32 students were asked, so you want to add up all of the numbers that are within the circles, so 14 plus 6 plus 7 is 27. I already forgot how many were asked. 32. So 32 minus 27 would be 5. So a 5 would go out here. Okay. Number 11. 37% of the students like ice cream, 15% of the students like cake, and 6% like ice cream and cake. Solve using any method you wish. Okay, so this is just like the ones above. So you're going to draw a Venn diagram, get your numbers, and then find the probability. So let's see. We can, since it's percentages, we can just pretend like it's 100 students, so we have numbers to use if that's less confusing. So we have ice cream, we have cake, and in the middle is both. So 6% like ice cream and cake, 15% like cake, so you do 15 minus 6 is 9. 37% like ice cream, so 37 minus 6 is 31. Okay, and then let's see, you're finding a probability. It's out of 100, since it's percentages, that's out of 100. So what's the probability that a randomly selected student likes ice cream or cake? So that means either. So in that case, it's everything within the circles. So that would be 31 plus 6 plus 9 is 46. So 46 out of 100, or 0.46. Also, we didn't say this, but we also have people who maybe don't like either one, right? So we can go ahead and find that. If we're using percentages, and that's 100, we would do 31 plus 6 plus 9 is 46. So 100 minus 46 is 54. So 54 people would have said that they didn't like ice cream or cake. They didn't like either one. All right, part B, they didn't like cake, but they did like ice cream. So if they didn't like cake, they couldn't be in the right-hand circle. But they did like ice cream, so that would be 31 out of 100, which is 0.31. Now we want to know how many didn't like cake and didn't like ice cream. So they didn't like cake and they didn't like ice cream. Okay, so that's how many like neither. So that would be the ones on the outside. So that would be 54. So that would be 54 out of 100, or 0.54. Okay, what's the probability that the person liked cake but didn't like ice cream? So that means they only like cake. So that would be the 9 out of 100, or the 0.09. E, didn't like ice cream, given they like cake. Okay, so this makes a difference. Given they like cake is a different denominator, right? Remember that 15% liked cake. So now my denominator is going to be 15. How many didn't like ice cream? So that would be the ones that were not in the middle. So that would be 9. So 9 out of 15 which as a decimal would be 0.6. Okay, let's see the next part. F, is liking ice cream and liking cake mutually exclusive? So no, it's not. Mutually exclusive means there's no overlap. And there is overlap because some people like both. So no, it's not mutually exclusive. Is liking ice cream and liking cake independent or dependent? All right, so this would be dependent. Okay, so the next one, let's see if I can fit all of this on here. Okay, we'll have to scroll it up in just a minute. The NIH is creating a test for the Zika virus. The incidence of a Zika is low, 2% in the general population. So that means 2% of the population would have it and 98% would not. Remember, percentages, it has to be a total of 100%. Okay, so the probability of, well, let's keep reading. There's a trial version, but it sometimes misses the disease. The probability of a false negative is 13%. Similarly, someone who does not have Zika will sometimes get a positive reading. The probability of this is 30%. Fill in the tree diagram. Answer in percent to 2 decimal places. Okay, so let's see if we can figure out how to fill this out. So probability of D or probability of no D. So probability of having the disease, I guess D means disease, and then the probability of not having the disease. So only 2% of the population has the disease, so that would be a 2, and you see the percentage is already there, so it's 2%. 98% does not have the disease. Okay, so now we have these conditional probabilities. If you actually do have the disease, so we're going to look at this top part, this 2. Some people that have the disease take the test and it tells them they have the disease. But some people that have the disease will take a test and it actually tells them they don't, but they really do. So it's a negative test result. So let's see. The probability of a false negative is 13%. So that means it's telling them it's negative, but that's false, is 13%. So remember that these two have to add up to 100. So 100 minus 13 is 87. So when they take a test, people who have the disease, when they take a test, out of 100 people, 87 will get the positive and 13 will get the negative, but they all have the disease. Okay, similarly, someone who does not have Zika, so that's going to be down here on the bottom, will sometimes get a positive reading. The probability of this is 30%. So the people who don't have the disease, they take the test, 30% of the time, it's going to tell them they have the disease, but they really don't. 70% of the time, they're going to get an accurate reading saying, no, you don't have the disease, and they really don't. So again, these two probabilities have to add to 100 as well. So these have to add to 100, and these have to add to 100. Okay, so now we've gotten that filled in. Now let's see what we have to do next. So now we want to have the joint probabilities. So what we want to do is we want to go down our list here. So this is 2% times 87%. And we're writing these as percentages. Okay, so what I'm going to do is I'm going to multiply, and I'm going to do it in decimal form because that just makes more sense to me. So if I multiply 0.02 times 0.87, I get 0.02 0.0174. So this is my decimal form. As a percent, I can move the decimal over 2 times to get a percentage. I'll get 1.74%. I'm going to do the same thing. I'm going to follow each trail. So let's follow the next trail. Next is the probability that they have the disease, but they get a negative result. So that we'll find by multiplying 0.02 times 0.13. We get 0.0026. So moving the decimal over twice, we'll get 0.026%. Okay, now we're going to follow the next trail. They don't have the disease. They get a positive result on the test. So this will happen 0.98 times 0.3. 0.294. So move it over twice. We get 29.4%. And then the last one is 98 times 70 percentages. So we're going to change it to decimal. 0.98 times 0.7 is 0.686. Move it over twice to make it a percentage, so 68.6%. Okay, so we've done now this tree diagram. So now calculate the probability that a positive test result means that someone has Zika. Okay, so a positive test result means someone has Zika. So in this instance, we are talking about a positive test result. So let's look at the paths where that can happen. So one path is it could be positive. Let me erase the highlights here. Oh, nope, I can't do that. Okay, so this is a 2. Okay, so I'm not going to be able to highlight, but let me just circle. One case is that they have the disease and they get a positive test. So the probability that a positive test result means that someone has Zika. So there's 2 possibilities that they have a positive test result. It could be positive and they have the disease, or it could be positive and they don't have the disease. So both of those are ways that it could be positive. So the denominator is going to be a positive test result, either path. So the denominator is going to be made up of the options or the ways that you can have a positive result. Okay. Your numerator is going to be that you have a positive result and you have Zika. So that's only the 1.74. Okay, when you divide that, you end up with 0.0558. Let's go ahead and round to an 8. Changing it to a percentage, you move it over twice. So you would get 5.59 if we're rounding. All right, 13. Event A occurs with probability 0.4. Event B occurs with probability 0.32. And the probability of A union B is 0.56. Okay, so this is an interesting way to give you the information. So let's draw our diagram. We have A, we have B. Okay, A is 0.4, so that means the whole circle A. The whole circle B is 0.32, and together the total is 56. Okay, so here's what you can do. If there's a formula that tells you can do A plus B, and then if you subtract the overlap because it's counted twice, you would get the total. So Oops. All right, so if we added A plus B, that would be fine, but that's not going to equal 56 because we counted the middle twice. So we're going to subtract off the middle, which is A intersect B, and that would give us our total A union B. Now let's fill in what we know, because we don't know the intersection. That's the whole problem with what they're giving us. A is 0.4. B is 0.32. We don't know the intersection, so I'm just going to call it X. We do know the union, that's 0.56. So now we can solve to find out what the intersection is. So again, we're trying to find this intersection, this middle part, because it didn't tell us that. And we have trouble filling in the diagram without that first. So let's see, 0.4 plus 0.32 is equal to 0.72. Then we're going to subtract 0.72 from both sides. So 0.56 minus 0.72 is equal to negative 0.16. So negative x is equal to negative 0.16, which means x equals 0.16. So the middle part is 0.16. If we know that A is 0.4, we can just do 0.4 minus 0.16 and get 0.24 here, because both of those have to add up to 0.4. So again, A is 0.4 minus the part in the middle. That's how we got 0.24. And for B, we know that B has to be 0.32. We can subtract the middle part there and we'll get 0.16. Okay, so if we add all three numbers that are in the circles, we should get 0.56, and we do, so that's a good check. Since this is probabilities, the probability has to be total of 1. So if we do 1 minus 0.56, we'll see that 0.44 is going to be out here. Okay, so now let's use that to answer the questions. So let's see what we have. Probability of A complement intersect a B complement. So what's not in A and not in B? The only thing that's not in both of those sets is 0.44, which is the stuff on the outside. So that'll be 0.44. B, probability of A and B. So they want that middle section, that intersection. That's the middle, which is 0.16. C is the probability of A given B. So the probability of A given B. Okay, so given B is your denominator. So that means given that it's in this set, this circle B, what's the probability that you'll get an A? Well, the stuff that's in A is just this. So it's 0.16. What I circled or highlighted is the 0.16, that's the numerator, over your whole B, which is 0.32. So 0.16 divided by 0.32 is 0.5. And that makes sense. 0.5 means half, right? Half of circle B is only B, and half of circle B is in the overlap. So that's where you're getting that 0.5 from. Okay, part D, the probability of not being in B, so complement of B, given that you're in set A. All right, I'm going to have to erase some of this stuff that I did real quick. Okay, so let me put this back, was 0.5. All right, so given you're in set A, so I like to read the given first. So given that you're in set A, so that's your denominator. Remember that set A had a total of 0.4, so that's the bottom. What's the probability that you're not in B? So the part in that set that's not in B is 0.24. So you would do 0.24 divided by 0.4 is equal to 0.6. Okay. Okay, so 0.6. All right, and the last part of this one, find the probability of A union the complement of B. So let's look at what that means. So A, so that's this, that would be this and this, because union means everything's coming together. And then we also have to include what's not in B. So that would be this out here. So everything highlighted is going to be added together. So we're leaving out that 1.16 that's not highlighted. So 0.24 plus 0.16 plus 0.44. So let me write this out. 0.24 plus 0.16 plus 0.44 is what we're adding up. And we get 0.84. Okay. Number 14, giving a test to a group of students, the grades and gender are summarized below. If one student is chosen at random, find the probability that the student got an A. Okay, so let's see. How many got A's? 9 got A's out of 45 students. So that would be 9 out of 45. It doesn't say if they want a decimal or a fraction, so if they want a fraction, 9 over 45. If they want a decimal, 0.2. Find the probability that a student was male and got a C. So male and C is just that part where they overlap. So it's just this, that's 7 out of the total 45. So we'll have 7 out of 45. As a fraction, if they want a decimal, rounded to the nearest 100th, it would be 0.16. Find the probability that the student was female or got a B. Okay, so this one, female is 31. Okay. Got a B is 23. But the problem is we counted this 20 twice. We counted it in the female row and we also counted it in the B column. So we'll have to subtract that out. So we will be doing 31 plus 23 minus the 20 that we double counted out of the total 45. So 31 plus 23 minus 20 is 34 out of 45. And if we want to find a decimal approximation, it would be 0.76. Okay, if one student is chosen at random, find the probability that the student was male given they got a B. Okay, so given they got a B means we're only looking at the B column. So that's the given. So the given denominator is 23. So it's going to be something out of 23. And it says, given that they got a B, we want to know the probability that it was a male. So 3 out of 23 are male. So the fraction would be 3 out of 23. The decimal would be 0.13. Okay, 2 more to go. So number 15, a bowl contains 9 cherries and 10 grapes. If you reach into the bowl and pull out 2 items in succession and without replacement, what's the probability that you pulled out 2 cherries? Okay, so 2 cherries, you have 19 total fruits. So you have 9 cherries out of 19. So you have 9 out of 19 chance of getting a cherry on your first pull. On your second pull, there's only 8 cherries left because you picked one. And there's only 18 fruits left because you picked a fruit. So you would multiply those together. 9 times 8 divided by 19 times 18. That would be 0.2105. At least 4 decimal places. So 0.2105. First a cherry and then a grape. So first a cherry, so that would be 9 out of 19. And then a grape. There's still 10 grapes left because you haven't chosen one yet, but there's only 18 fruit left total. So that's how you would set that one up. So 9 times 10 is your numerator. Your denominator is still 19 times 18. You get 0.2632. Okay. And then the next one, a grape second, given that you got a cherry first. Okay, so the given is that you got a cherry first. So our denominator, we have to figure out how could we get a cherry first. So we could get a cherry and then another cherry, or we could get a cherry and then a grape. Both of those would be the only ways that we could pull out two fruits and get a cherry first. Okay, so we actually have found both of those scenarios in the first two parts, part A and part B. So we're just going to use those here. So the cherry is part A, and the cherry grape is part B. So we have that information. So this would be 9 out of 19 times 8 out of 18. And then we're adding that to the cherry grape. So that'd be 9 out of 19 times 8 out of 18. Oh, I'm sorry, 10. 10 out of 18. Okay, so that's the possible ways you could pick a cherry first. The numerator is just going to be what you actually want to happen. You want it to be a cherry and then a grape. So that's going to be the 9 out of 18. Oops, I keep getting this wrong. 9 out of 19 times 10 out of 18. And then you're going to put that in your calculator and figure it out, and you'll get 0.5556. All right, the last one, a cherry first, given that you got a cherry second. Okay, so the way you can get a cherry second is you could get a cherry first and a cherry second, or you could get a grape first and a cherry second. So the CC we've already figured out. That's in part A. So that's going to be 9 out of 19 and 8 out of 18. Plus, grape first, we haven't figured this out yet. So if a grape first, there are 10 grapes and 19 fruits. A cherry, there's still 9 cherries left, but only 18 fruits. And then the case that we want is a cherry first, given that you got a cherry second. So we want the cherry option on top. So 9 out of 19 times 8 out of 18. All right, if you do that and you put in your calculator, you get 0.4444. Okay, our last one has 3 different parts. So a ping pong ball is drawn at random from an urn consisting of balls numbered 2 through 10. A player wins $1 if the number on the ball is odd and loses $1 if the number is even. What's the expected value of his winnings? Okay, number 2 through 10. So let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to highlight in red for the loser. So a player wins if the number on the ball is odd and loses if it's even. So he loses if he gets an even ball. So how many even balls are there? 1, 2, 3, 4, 5. And there's 9 balls. So 5 out of 9 times he loses, and he loses $1. Okay? If it's odd, then the player wins $1. So there are 4 ways to win. So 4 out of 9 times he'll win $1. So if we add these together, we'll get the expected value. So that's going to be negative 5/9 plus 4/9 is going to be negative 1/9. So since we're dealing with money, it's probably good to go ahead and give the decimal approximation. So that's going to be negative 0.11, so about negative 11 cents. Okay, the next part. A card is drawn at random from a standard deck of playing cards. If it's red, the player wins $1. If it's black, the player loses $2. Find the expected value of the game. Okay, so half of the deck is red and half of the deck is black. So he has 1/2 chance of losing, and he loses $2. And then you're going to add that to the expected value of the winnings. So half the time he'll get a black card. Oh no, a red card is winning, and he'll win $1. Okay, so we're going to combine this to get the expected value. This will be -1 plus 1/2 is going to be -1/2. So as a decimal, that's -50 cents. So you're on average losing 50 cents per game. All right, the last one. In a class, there are 20 students. 3 are 5'6", 5 are 5'8", 4 are 5'10", and 4 are 6 foot, and 4 are 6'2". A student is chosen at random. What is the student's expected height? Okay, so instead of doing decimals, I'm thinking of just switching to inches. So there's 12 inches in a foot. So for this 56 inches, we have to do 5 times 12 to get how many inches that is. So that's 60 inches, and then add it to the 6 that's here. So this will be 66 inches. So again, multiply the feet by 12 and then add it to the inches. So 5 times 12 is 60, plus 6 is 66. So we're going to use 66 inches. And then we're going to do the same thing all the way down. So 5'8" would mean 68 inches. 5'10" would be 70 inches. 6 foot would be 72 inches, because we're just multiplying that by 12. And 6'2" would be 74 inches. Okay, so it's going to be easier just to have it all in one kind of unit of measure. Plus the answer says it's in inches. So we'll go ahead and convert everything to inches. So now we're going to do 3 times 66 inches plus 5 times 68 inches plus 4 times 70 inches let me do this in terms of probability, since that's what we've been doing. I was going to look at it another way, but that's not a good idea. Okay, so let's do probability. So how many do we have total? We have 3 plus 5 plus 4 plus 4 plus 4. Okay, so there's 20 students. Oh, and it told me that right there. So 3 out of 20 times, we're going to get 66 inches. 5 out of 20 times, oops, we're going to get 68 inches. 4 out of 20 times, we're going to get 70 inches. 4 out of 20 times, we're going to get 72 inches. And 4 out of 20 times, we're going to get 74 inches. So the probability of drawing a person of each height is given next to the height. So you multiply those and then add all those together. So 3 divided by 20 times 66 would give you 9.9. 5 divided by 20 times 68 would give you 17. 4 divided by 20 times 70 would give you 14. 4 divided by 20 times 72 would give you 14.4. And 4 divided by 20 times 74 would give you 14.8. So now we're going to add all those together. 9.9 plus 17 plus 14 plus 14.4 plus 14.8, and we'll get 70.1.